So now let's go through the wastewater treatment. We know that wastewater is not good. Yeah, it smells not good, and of course we cannot drink it, and they're always linked to the pollution. But yeah, that's the truth. So when we're talking about this, we first need to know that it consists liquid and solid waste all together. And if we leave it untreated, there'll be pathogens. You know the pathogens. They can let us sick, and if we pump it into the water, it will also pollute the water and affect human environment. So we should make sure that they are treated before we pump it back to our nature or reuse it for other purpose. And there's some key terms you should know. First is sludge. Sludge, they are the solid that are removed from the wastewater treatment. You know, some solid like this. It can be anything. Just some sedimented part of the wastewater. And basically, we can use some ways to remove it, such as filters or some chemicals or some methyl, yeah. And when they are the stuff like left behind. There can be some other interesting things. First, for the solid part, there will be suspended solid. Or fixed solid. Suspended solid are the ones that are floating above the water, like this stuff. These are suspended, yeah, above the water surface. They can also be the fixed solid. And these also refer to the insoluble content in the wastewater. There are also unfixed solid, which are the soluble solid. Later on, we will get them short forms. Moreover, there are also biodegradable organics. Biodegradable organics are, yeah, they are also part of the waste, but they are linking to the chemistry part, some sources that can be degraded by the microbacteria or something related. But most important thing is that they are the content in the wastewater, like those nutrients. And also the nitrogen or phosphorus. They need to be removed because they can cause some eutrophication in the existing water sources that can further pollute it, because these nutrients are loved by those pathogens, you know, like those microorganisms in the water. If there are too much, yeah, there'll be too much of them on the existing water and cause some polluted issues. Okay, so after we talk about the key terms, we can talk about the treatment method. There are various types of treatment method, but to sum up, they can be summed up into a few points. First is the preliminary treatment, and then is the primary, and then secondary. There might be tertiary, those things, but yeah, it really depends on the treatment system. But the overall principles and the treatment method are generally similar to the secondary or primary, but some of them have some specific designs. It depends on the situation. And there are also some keywords for you to know. SC, that's a sewage charge. Sewage charge. CSO, that is a combined sewer overflow. Also, CSS, combined sewer system. These are linked to the overflow. Yeah, overflow is just like a cup of water, and those waters are flowing out. Let's overflow. Too much water, overflow. And TS. TS is the trade effluent, surcharge, wait, okay, so we continue from TS. There's also something linked to the treatment method, like CEPT, chemically enhanced primary treatment. They can remove some total, like remove some solid and biological content. So to be specific, right, we can have organic matters, nutrient, and solid in the wastewater. And every time when we're talking about wastewater treatment, there's a standard method that's been followed that regulates the solid pathogens, heavy metals, and organics for time to time. So it also have a like standard book that talk about how to treat all these things. So it's quite a well-rounded topic. It's been existed for almost 100 years. So overall, it is a good system, and we are still using this system, but with more advanced technologies nowadays. And because this is also linking to some other related aspect. First is conservation of mass. When we speak of conservation of mass, yeah, it is related to total mass, that there's no loss and no gain, just a complete system. Because it also linking to the reactions, batch, plug flow, and yeah, plug flow reactor and the completely mixed flow reactor. So overall, it is a method that we should consider. For the batch, it's just a like fixed system, nothing flow in, flows out. Plug flow reactor, it can be a like a tube, yeah, continually flowing. So we also can call it PFR. And for the completely mixed flow reactor, we also can call it CMFR. This CMFR is like a system where there's continue in and continue out. And inside here, the concentration is the same. And if we want to elaborate a bit more to draw a graph of them, you can see that if we plot concentration and the time graph, this is a steady state. But if system is not at a steady state, you can see that concentration is fluctuating. That's not a steady state. So not a steady state. We like the steady state situation because it's simplified lots of stuff. And for our reactor, for the PFR, plug flow reactor, we can see it as this. This is concentration, this is time, time. That one is actually continuing lower, when we are switching the distance. Because you see, that's a tube, right? As it flows through the mixed liquid, it's steady flow. Switching the distance as time goes by, the concentration here will decrease. Concentration here in this closed system will decrease. And for the CMFR, you can see that the concentration inside can be a bit higher, and the concentration out is a bit lower. For the batch flow one, that one just have the same concentration after all. And after knowing this, you're almost done with the basic knowledge of wastewater. But there's some other things you might need to know. Like when we are talking about the reaction, because there's always a reaction happening when we are treating the wastewater from the organic matter treatment and nutrient treatment. So there's some reactions we need to consider. And in this scenario, we're just talking about a steady state reaction. And we can have our formula like this. dV over dt, V is equal to QC, the concentration, Q is flow rate, minus QC plus RV. This one is the inflow rate. It's like in. This one is out. So you can see they have different concentration, and this is the volume. And this is the reaction volume. Oh my god. This one is volume. Okay. And when we are talking about the reaction, it can be linking to the orders of reaction, mainly R is equal to K. That's zero order reaction. Or the R is equal to Ka, the first order reaction. Or R is equal to Ka squared, that's the second order reaction. In this scenario, we are talking about the dA over dt. Thus, we can say that rate of accumulation is equal to inflow rate minus outflow rate, and then plus net transfer rate, net transformation rate. Yeah. This net transformation rate is basically this part. And yeah, if we're talking about steady state, we should know that Q in is equal to Q out. So the inflow is equal to outflow in terms of the rate. Okay, now that's the overview of the wastewater treatment system.